super excited to have you here, man. I really love the first conversation we had a few weeks back or a month back. And I think that it is going to be very informative when it comes to what we were just talking about, like limits of stateful set, also networking trade-offs that you have to keep in mind when you are running data on Kubernetes, and the random shenanigans that comes with having my man Bart in the in the conference room with us, whatever you want to call this. I don't know.
Random shenanigans guaranteed.
Yeah.
Will not fail.
Or so if you are new here, we are giving the podcast a try. We have our weekly meetups, and those are a lot of fun. I encourage you to jump into them. But I also wanted to talk with Tyler before the end of the year, and we have our meetups all completely full. So we said, let's just do a podcast and put it out there because you've got a lot of wisdom, Tyler, that you can impart on us. And I don't think it can wait until next year.
Yeah, but I would say, looking into the future, I predict that there will be a meetup in which Tyler will be participating and leading.
There we go.
Yeah.
There we go. Round 2 will
Oh,
be
definitely. Yeah.
the meetups fashion. So, yeah, I guess it's about time that we have you introduce yourself, Tyler. Can you give us a bit of background on what you have been doing, how you got to be where you're at?
Yeah, sure. So thank you for having me, Demetrios and Bart. Uh, I am currently my name is Tyler Duzan. I'm currently the product manager for network security at Mozilla. So I work on the Firefox desktop team, and I'm also working on Mozilla VPN. But prior to that, I spent quite some time at Percona, which you may or may not have heard of, but if you're in the database space, you probably have. And one of the primary functions I had at Percona was being the technical lead and product manager for all of our cloud and container strategy stuff. And one of the things I did while I was there was bring Percona XtraDB cluster into Kubernetes, as well as Percona's MongoDB product, Percona MongoDB server, or Percona server for MongoDB rather, into Kubernetes with an operator. And in that vein, I gave a talk last year at KubeCon about how network performance affects database performance in Kubernetes with Vadim Tchenko, who's the CTO of Percona, as my co-speaker. And prior to that, I was an engineer for almost, 14 years almost, working in the cloud space primarily, starting with my time at Rackspace and doing a few startups after that, before I found my way to Percona.
So, if anyone doubts your engineering ability, can you just explain what you had in your closet before a few weeks ago? Because I found that fascinating how you're running basically your own lab in your office.
Yeah, so, well, in my closet, I used to have basically a whole rack of, well, it was an IKEA lack rack. So if anybody doesn't know, you can get the right size of IKEA lack tables for like $10 a pop. And they happen to have exactly 19.1 inches between the inner dimensions of the legs. And they happen to be roughly the same length when placed in the correct position as a full depth server. So you can turn them into a rack pretty easily. So I had a lack rack in my closet, and I had like 8 Dell servers that were fully populated, and I was running Kubernetes. I was using Origin, so OKD, and I had Mesosphere DCOS running in there, and I also had a VMware vSphere cluster, and that was my home lab for testing out different cloud stuff. But if you can see, for those that are watching the video, out the corner, you can kind of see like some shiny reflection coming through the window from the light. That's brand new hardwood flooring. So I'm like redoing home renovations, and as part of that, I ripped all of the servers out of the closet. May come back, but for now, I moved all of my stuff into the cloud proper and ripped all my servers out of my closet, and now just have like one little box in there for storage for backups.
Yeah, and so that was where you were doing all these like benchmarking tests that you spoke of.
Well, for the talk I gave at KubeCon, Percona actually operates a a research and development arm called Percona Labs, which the CTO Vadim runs. And so they actually have in an actual data center, they have a significant amount of equipment, which is specifically for benchmarking and testing database performance questions. So Percona specializes in database performance.
Nice. Very cool. So we have a lot of ways that we can go here. I think it would be interesting if we started talking about just Kubernetes and data and your feeling on that and how that position has come to evolve over time, because I know you've been messing around with Kubernetes for quite a while, and what you've seen the evolution be and now where your stance is.
Yeah, I mean, when we first started assessing like how we wanted to bring some of these more traditional databases like MySQL into kind of a cloud native environment, we looked at Kubernetes and initially rejected it. This was like in late 2017, and at the time, operators as a idea existed, but the operator framework SDK hadn't been created yet by Red Hat. It hadn't really been publicized. You know, the kind of the blog post that CoreOS wrote about the operator pattern hadn't been written yet. That came out in like I think April of 2018. So at the time when we looked at what was out there in the container space specifically, you know, there was a lot of players, and while Kubernetes had a lead, from the database perspective, DCOS was really interesting to us, and Apache Mesos, and there was stuff like the Smack Stack out there. So we initially invested in putting databases into Mesos through DCOS with a data framework for DCOS. But as we went into 2018 and operators became a thing, we saw an opportunity to really bring databases to Kubernetes. And I think that stateful set alone is not enough to bring data into Kubernetes successfully, but operators make it possible.
With that in mind, you know, because a lot of times what we encounter for different people is different folks out there that maybe are considering getting on, you know, bringing their data onto Kubernetes. Some people feel a little bit intimidated. Sometimes it seems like maybe it's not exactly for everyone. What are the factors that you think that people should keep in mind if they want to get involved in this? I mean, we know there's going to be an element of patience in getting onboarded, but what are the technical things and perhaps non-technical things that people should keep in mind if they're thinking about taking that step?
Yeah, I mean, I think bringing your data into Kubernetes is not necessarily appropriate for every single application, but I think there's a lot of advantages to it from a portability perspective, but there are some trade-offs. So obviously we've talked a little bit about some of the network performance trade-offs in reference to the talk I gave last year at KubeCon, but I think additionally, you need to just kind of think about what your application's doing and how you're making use of that data, and that will help to guide the right decision. So I think one of the best things you can do is to data model appropriately, pick the right database management system to meet that data model. And if you want to bring that into Kubernetes, keep in mind how well that database management system works with Kubernetes as you make the decision about where you should home that data for that application.
Yeah, that was something that we were talking about just before this. Before we hit record, we were talking about like how databases really, well, not all of them, let's specify that first, but a lot of these databases have been around before Kubernetes was a thing. And so now you're having to take something that was made with its own assumptions and you're making it fit into the Kubernetes way. And you're saying, all right, I'm going to try and put this together. Like, what are your thoughts on that and how well the databases that were around before and are opinionated on certain things, but now they need to squeeze and be in the shape of Kubernetes? Like, what does that look like and how can we deal with it properly?
Yeah, I think that's one of the areas in which operators help a lot, because there's a lot of these like integration steps that hopefully a database vendor is doing for you. But there's a lot of these integration steps that have to be taken to make more traditional database management systems work well in a containerized environment. And there's some limitations in stateful set that can be really impactful for databases that weren't built with Kubernetes in mind. Stateful set requires that you start up either randomly or you start in a specific order where pod 0 always starts first. But if you're dealing with a database that is a more traditional style, like let's say MySQL. So let's talk about MySQL with Galera, like Percona XDB cluster. In this case, it's using synchronous replication, which is good because it guarantees if a pod goes down or is moved somewhere else or is evicted, you end up still having great data consistency and all of that. But if for some reason every single pod running your database were to stop, to get the database cluster back up and have data continuity, you have to start in a very particular order. Whatever the last member of the cluster to stop has to be the first to start. That's pretty common in a lot of traditional databases to deal with guarantees of data consistency. But because of the startup ordering issue in stateful set, it's not really possible to deal with that just running stateful set raw. But operators provide you a pathway to have that tighter integration and to take automated actions to recover from those sorts of situations.
Yeah, for sure. And one thing that I think comes up in the community chat quite a bit is the question of when you're dealing with databases and you're dealing with storage solutions, how to manage the different replicas between the two layers. And do you just make sure okay, I'm just going to get replicas on each level and so then I'm totally safe? Or now, well, that actually is a little bit overkill. Should I just route all the replicas to one? Have you seen a good way of doing that?
Yeah, I mean, that's a really good question. There's a couple of ways to approach this. You can certainly rely upon storage replication. And this is something that some folks have done historically with databases. Generally, you have things like DRBD, for instance, as a more traditional pathway to do that. In Kubernetes space, there's some storage vendors out there that kind of do replicated based storage, and you assign a PVC to a pod, and it just has storage available that's been replicated. But the challenge to that is when you use the storage replication, then your database isn't necessarily aware that it's been replicated. So generally, if you were going to do something like that, you'd want to build an operator specifically for that use case, if one doesn't already exist, that has some awareness of the underlying storage. Or in some cases, there's some storage vendors that provide their own scheduler that you can use instead of the default Kubernetes scheduler that has some awareness of that can integrate with existing operators. The flip side of that is if you do everything in the database layer, then the database layer, at least for traditional databases, has no awareness of Kubernetes. It doesn't know what Kubernetes is or how it operates. It doesn't know that it's running in a pod. It doesn't know the limitations that it operates under. And generally are built on the assumption that they're running on bare metal hardware that has all sorts of levels of physical redundancy, so that downtime is rare. And so it's going to replicate differently than maybe storage is going to replicate on the other side. Combining the two also has trade-offs in that you can end up having contention, right? Whether that's a space contention issue where you have so much replication happening that you're using 5 times the storage you actually need, or it could be a contention issue around I/O operations where replication has a cost both at the network level and at the disk I/O level. So I think you have to just be aware of those things and then make the trade-off that seems best for your application. I think there's no one size fits all solution. And that's one of the great things about Kubernetes is it has a ton of flexibility, but it provides one kind of unified abstraction and API that you can treat as the operating system for the cloud. So regardless of what sort of infrastructure you're running on, you can rely on the community to help guide you to make the right decisions about those trade-offs.
And speaking of trade-offs, there's A lot of different conversations about, obviously we've already touched on storage, we've talked on networking, and something that seems to be a bit scary for people, because about a month and a half ago we talked to a guy from IBM, Asier Arzaceta, who's a cloud security expert. And speaking of trade-offs, is this thing of like, we're leaving a monolithic scenario. We're talking about sidecars, we're talking about orchestrators, we're talking about you were mentioning, awareness, self-discovery, things like that. Now that your new role is more focused on the security side, how does security enter into all of this, and how can it be a part of the equation from the very beginning in order to avoid maybe very heavy trade-offs later on regarding cost, regarding training, a lot of other things that go along with that?
Yeah. So there is definitely a security aspect to all of this, and there's kind of maybe 2 layers to it, or 3 layers to it probably. So I think that when you decide to deploy Kubernetes originally, like even before you get to the should you or should you not put data onto it, you have to have an awareness that even though you're running your application stack and all of the goodies inside of the Kubernetes environment, Kubernetes itself has a host environment, and that host environment still needs like appropriate security policy enforcement and security barriers. And I think what's great is there's lots of options now to do that in a pretty simplistic way. I mean, even going back, we had like CoreOS where you could basically deploy a server that is essentially read-only in the host environment. So, and it's all locked down. So keeping that in mind for hosts is important. And then once you go into the actual Kubernetes layer itself, I think it's important to think about how you build your containers and following those best practices for the appropriate way to build, Docker containers, like don't run services as root, things like that. But also there's some things you can do now. There's things like svert that allow you the opportunity to really provide stronger security barriers between containers by making use of like kernel level security enhancements. And implementing those things can really improve the amount of isolation that a container has as compared to, say, like a virtual machine. That is obviously a trade-off a lot of people consider from a security perspective when they decide whether they want to use VMs or containers, is the amount of security isolation they have. So there are ways to address that. It's not perfect. There's always going to be trade-offs, and I think each of those things has to be considered in how it reflects upon the specific application you're running. Like you may make different trade-offs if you're trying to protect the Coca-Cola recipe versus if you're protecting a database full of cat pictures. So those have different.
The Coca-Cola recipe is super on lockdown, huh?
And never underestimate the importance of cat pictures.
Yeah. And then once you get into the database layer, then there's a whole nother level of like security questions you have to answer, and it's very DBMS specific. But one thing I have seen is legitimately the low-hanging fruit matters a lot. I think there's different ways to address security, and a layered approach is probably the best approach because you need to have multiple layers of defense. But at the end of the day, it's kind of like that old joke about running away from a bear in the woods. You don't have to be the fastest, just don't be the slowest.
Yeah.
And in a lot of cases, there's so many folks that go out the door just running stuff publicly on the internet with the default settings that just taking the time to read the documentation and follow the instructions will put you ahead of everybody else.
And in terms of your professional trajectory, you've obviously been in a lot of different areas, worn many hats. Was there anything? What was it about security that particularly caught your attention? That you're like, hey, I think there is something we might need to get into this more. That you saw that it matches up with your skill set. What is it about security in particular that really made you think, hey, I want to dive deeper here?
So I've been interested in security pretty much my whole life, and it's actually been somewhat the driver for all of the other changes that I've made in my career. One of the very interesting things is for folks who know how IT career trajectories typically work historically in the industry, is I started out in hard Microsoft space, and then went to the Linux space, and then I was well, actually, I started in the hardware side, hardware and networking side of things, then went into Windows,
Yeah, because
really hard,
you're
then went into Linux.
because for your specifically for your studies, what did you get your degree in?
Well, I actually don't have a degree, interestingly enough.
Right.
So I went to school for electrical engineering, and then I dropped out.
Ah, okay, okay.
So, but yeah, I bounced around because one of the things about security is something that exists in every aspect of technology, almost in every aspect of life. Like, and so there's so many variations to it. You have to consider it from every angle. And that's why taking a layered approach is important, is because if you don't take a layered approach, every choice you make, every engineering decision you make has trade-offs. And so sometimes you can paper over some of those trade-offs by solving them in a different layer. And security really forces you to think about those sorts of things carefully, because even one little crack in the armor and one little chink and you could be done. So it's something that requires a very serious analytical approach, I would say.
And not so much from the sense of being, paranoid, but just let's get a full vision of seeing everything that's going on and consider different what ifs, not necessarily from a panicky base, but just from due diligence, best practices. Let's make sure this is well built.
Yeah, absolutely. I don't think anybody needs to be paranoid, but it's worth considering, every aspect of your environment. And the great thing, I think, is that security is so much easier and more approachable now than it ever has been. I mean, the quality of software that we actually use in our environments to build our infrastructure and build our application stacks is so much higher now than it used to be. I mean, the benefit of open source and community-driven development it is largely that the types of low-hanging bugs that don't make people usually think they're important still get fixed because someone cares about it. And a lot of times it's the little things, the small details that matter when it comes to security. So I think the overall security level of software today is so much better than it was, I mean, back just 5 years ago, 10 years ago. And as we build environments that are more heavily abstracted from the infrastructure with technologies like Kubernetes, we have the opportunity to kind of mentally put that stuff away and then focus our mental energies into improving our application security and the application code itself, and working in a more abstracted environment where we can focus on those things. I mean, there's great stuff happening in the Kubernetes space with policy stuff with OPA and doing service mesh and policy-driven networking. And I mean, all of those things help to improve the security of your environment and do so in a way that's approachable to a typical application developer.
So I'm gonna pump the brakes a little bit on the security talk and bring you back around just because you said something earlier.
How dare you? We're doing so well.
I know. I love the security talk too, but I wanted to touch on this point that you mentioned earlier about, and actually have you expand on it. Like the way that you see Kubernetes is like an operating system for the cloud. Can you talk about that a little bit more?
Yeah. So I think one of the things that we see is technology has this kind of cyclical pattern to it a bit. And if you think from the perspective of a developer, and you're let's say you're doing some greenfield application and you have to decide what you want your app stack and your infrastructure to look like. There's these moments in time where you can choose something that is universal enough that it gains you all this extensibility, all of this capability, and you can just build on that. And you don't really have to worry about a lot of the details underneath. And all the time in between those swings in the cyclical cycle, you have really focused, very specific choices you're making. And I think the cloud is exactly like that as well. So when the cloud started out, it was kind of like you could pretty much choose to just not worry about the cloud vendor specifically, because you're buying raw infrastructure and you only had to care about building your apps correctly for Linux, because wherever you were at, you were running Linux, so it didn't matter. But now it's like, you open up the Amazon AWS console and they've got like what, 600, 700 different AWS products, and you can like build this thing that's like super deep into their APIs, and that's really cool.
Yeah.
But now
Fun
you're
fact,
stuck
I'll
on
try
AWS.
to.
Yeah.
Yeah. I'll try to link to a quick like web page where it explains all of the different services that AWS offers and all of these like acronyms and what they mean. But
It's intimidating. I mean,
yeah.
there's so many things. I mean, I don't even know what all of them are. I used to like have them all memorized. I couldn't even begin to now. And the amazing thing about Kubernetes is it provides you all of the things you would expect from a cloud, but it's abstracted away from the underlying infrastructure of that cloud provider in such a way that you have the same environment to build your application in, regardless of whether your Kubernetes is running in GKE or you installed, OpenShift on top of EC2, or, you're running AK. It doesn't matter. You can run any infrastructure, any provider, and it's the same. You get this batteries included environment to abstract away all of that. So that's why I say it's the operating system for the cloud, because at the most fundamental layer, like what you're working with as an application developer from an abstraction perspective is like the tools and the libraries that are included with your operating system, right? And so I think of Kubernetes as being like an operating system, a distributed operating system.
That's such a good way to look at it. I wonder though, because I think we've heard this a few times in the meetups, talking about how it's not exactly similar. Like right now, if we wanted to put Kubernetes on GKE, it's much different than if we want to put Kubernetes on AWS, right? And it's not like the cloud service providers come to you. It's like you have to go to them in a way. You have to make the effort and do it their way instead of everyone doing it in a very uniformed way. And so I'm wondering, do you feel like that is an issue? Do you feel like that is something that could be solved?
I mean, I think that those cloud providers have a very strong business motivation to try to differentiate from one another, both as a way to express some sort of like value they provide to the market, but also as a way to entrench you and get vendor lock-in. So they're motivated to make sure the experience is similar enough that it's easy to migrate, but different enough it's hard to leave. And um, they're going to do everything they possibly can when they choose to host Kubernetes for you, rather than you running it yourself on top of like raw, dumb, virtual machines. That's going to create that experience for you. But to a large degree, those are operational differences rather than differences that affect the fundamental capabilities of building your application stack on that environment. So it's something that you're going to see that ops teams are going to deal with more than maybe app developers, except for folks that are really hard into like doing DevOps model stuff. But I think one thing you can do to help yourself, and this comes back to like running databases on Kubernetes, is don't make use, if you want the portability, don't make use of all of the nice bells and whistles that your cloud provider wants to give you. Just use Kubernetes. If there's something you need, do it in Kubernetes. So, if you're, say, on OpenShift on EC2 and you need a database, don't be tempted to just pop an RDS instance, because now your data is in RDS, right? Go ahead and figure it out. Get your data into Kubernetes, and then you can just migrate it with everything else.
Yeah, but I think it's a common theme in this conversation has been the issue of trade-offs, and so I think a lot of times is I'm always been a Microsoft guy, and so we're running everything on Azure. But then I have a conversation with an AWS guy that says, as you rightly just pointed out, oh, don't worry, the transition's not going to be that big. But of course, this is trying to pull you deeper and deeper into whether it's licensing or getting hooked on these things. And maybe it is a great experience, but it's not that you have to be rude anytime somebody calls you trying to offer something, but just thinking about the eventual goal is to get you sucked in, I guess we could say. And which is a thing that comes up in a lot of the meetups is whether we call it hybrid cloud, cross cloud, multi cloud, is having to keep that in mind as a mentality that this is the best way to go forward. And last week in our conversation with Gary from Cloudy, and that was a big thing as well too about avoiding vendor lock-in. That almost needs to be part and parcel of a good company's DNA if they really want to not get trapped into have the best options based on the technology and not just on, like you said, the bells and whistles that might come along with one or another.
Yeah, absolutely. And I think there's actually some really great business advantages there as you scale too. If you think geographically, as you choose where your business is going to grow in the world strategically, you may pick different providers based on what they have as available points of presence. And so if you're able to leverage the portability of something like Kubernetes, then you can choose to have relationships with multiple cloud providers. You're not obligated to choose one, you can choose many.
That's a super good point because, like, here locally speaking, where I live in Spain, there aren't that many companies that are working with Google Cloud. Like, that's just not. That's historically many people trapped in, like I said, for long periods of time with Microsoft. Some people with IBM, and then an increasing amount. I would say the fastest growing, I would say, would be AWS. That seems to be like very, very aggressive. And as you said, there are so many options. It's like walking into like a supermarket full of different things and things that can be learned or added or modified. But I think that you said, particularly as companies have much more of a global approach, we see people working in all corners of the world. So it's that if people have experience with one provider or another is what's going to make them feel the most comfortable. But having that flexibility that you're able to tailor things based on local needs.
Yeah,
Bart,
absolutely.
nobody uses Alibaba Cloud in Spain?
Not that I know of.
I don't know if anybody either using that, but it goes back to Tyler's point on your geographic location. Maybe if you're trying to do stuff in China or in the Far East, you want to be in Alibaba Cloud and you want to be running that. So there was another thing that, like you touched on how stateful sets are not enough. You said it's just not realistic to think that you should only have that tool in your toolbox when you're dealing with Kubernetes if you want to be doing stuff with data, right?
Mm-hmm.
And before we started recording, you also mentioned this nice metaphor about data being an anchor. Can you explain that to us again? Because I think that is a really easy visual interpretation of what's going on.
Yeah, absolutely. And I think it ties perfectly back to what we're talking about with portability between clouds as well. So, the thing about data is that it's, I don't want to say it's an all or nothing proposition, but it kind of has the feeling of being that. Data is important. You need it to be consistent. You need to have continuity. You want to make sure you don't have any data loss. And so you need to have integrity. And to have all of these things, you kind of have to like take all of your data or none of your data for a given application when you're moving it around. And so data migrations tend to be like one of the most nerve-wracking and difficult things that a technology group will do within a company.
Yeah.
And so data has this like anchoring effect. It's like, because it's hard, it's the thing you want to put off because you're like, we can move all this other stuff. We'll get to that eventually. Or, it's scary. What if we lose everything? Like, let's just leave it alone. And so there's this anchoring effect to it. So I think of data as being like this anchor, but an anchor can be a good thing and it can be a bad thing. An anchor holds you into a stable place. It can provide stability that guarantees you won't drift off into the distance. But an anchor can also hold you back from moving on and riding the waves of the future. And so I think one of the things you have to think about is what it means to get that portability and whether that's relevant for your application. If you bring your data into Kubernetes, now you've lifted anchors and you're riding the waves. But if you want to keep your data outside of Kubernetes, you don't get the portability to move your application just because it's running in Kubernetes, because you've got to have the data to run the application. So, if you put your data in Amazon Aurora, you're not migrating to GKE over a weekend. Like, it's just not happening,
Yeah. And I can see Bart scribbling frantically because he loves to make these videos on different themes and concepts. and then animate them and have it be this metaphor. I think I know what the next video is going to be that Bart
Yeah,
would
yeah,
make.
no, that's well, I'll be listening to this afterwards to think about how we can get it. But no, that's a very, very good visual. And as you said, once again, common theme here: trade-offs. It can provide security and stability, or it can be a hindrance or something that's holding you back to be able to move on. It's just, to touch on once again what the conversation we had last week with Gary from Cloudian is that, yeah, he just said the basic premise of, like, in general, you don't want to have to move your data, and if you do, there are going to be certain things you want to keep in mind. Just in the same way that if you have to move your furniture from one house to another, is everything going to arrive exactly the same way as when you packed it? Are you going to use lots of bubble paper? What are you going to do to avoid things getting broken, scratch, etc.? And data is no exception when it comes to that, moving. When it comes to moving it around, and as you said, portability is a big topic that that we hear about from a lot of different folks that we talk to. When it comes to portability and security, anything you could add there?
Oh yeah. So I would say one of the things to really keep in mind, and this is where like abstractions start to become leaky, right? So so you've got, let's assume you've got everything in Kubernetes and you're moving from one cloud provider to another. So maybe from the applications perspective, everything's the same, but that doesn't necessarily mean everything's the same below that layer. And below that layer could be critically important to you from a performance perspective. It could be critically important to you from a security perspective. So it's still really important to assess, the full stack that you rely upon to run your application and the trade-offs you're making with that stack before you make any sort of migration or move. Certainly the experience is not going to be identical between providers because they're different for obvious reasons. They're different. So that's a big consideration, and it really does heavily tie in specifically with performance and security. I think are the two areas I would key in on first and foremost when you consider a migration like that. Once you've got everything already in Kubernetes and you have the portability, but if you haven't yet moved your data into Kubernetes, there's significant also performance and security trade-offs to consider there.
So one thing that we talked about also is the idea of, what was it, storage brokers
Service
and
brokers.
service brokers, and
Yeah.
how those like didn't become a thing. And you really thought like this could potentially solve some problems. But then we looked at it and it seems like maybe there's a little bit of like somebody's flirting with the idea again. Can you just explain to us what those are and why you think there's potential there?
Yeah, so I really like the concept of service brokers, and what it started out with is, okay, so there's this thing called Open Service Broker API, and it was created by like a group of different companies that came together to build it, and it works off the concept of service catalogs and service registration. So the idea is that, like, let's say you want to deploy an application, and that application needs a MySQL database. So you can create that application within, whether that's within like OpenShift or like Cloud Foundry, or even if you want to like create it on top of Azure, you create your application, and there's a set of service brokers available in the service catalog that can provide different types of resources. And you specify you need a MySQL database, and there's an associated service broker that provides that resource, and it goes out and does the work to allocate and create that resource, and then it gets bound to your application in the service registry. So there's like this relationship made that this application goes to this database instance, and then they kind of like have a shared life cycle. They live together. So if at some point in the future you decide to like delete that application or that application instance, it can optionally delete the database with it. And so it's the idea of like having a set of like fungible resources where you choose ahead of time how you want to provide those resources. It could be, say, a hosted instance like a database as a service instance like RDS, or it could be, running a MySQL operator on Kubernetes, right? And then when you go to deploy an application, you just define what the minimum set of requirements and prerequisites are, and it's the service broker's job to figure out how to fulfill those. And I just like that concept. I think that's a fantastic concept. It just never got developed to the point that I would have hoped to see it, and it seems to have fallen to the wayside.
Where did it get to? And also shout out, nice use of vocabulary there with fungible. I don't even know what that word is. I just got to mention that.
Yeah, I guess fungible is
it's all good. I'll look it up. I'll Google it right now.
Yeah.
And when you finish this question, I'll let us know what it is. But where did we get to as far as service brokers go?
Well, I think where we got to was that some vendors really well integrated it into their products from the service catalog perspective and the service registration perspective, and they implemented the concept of application binding, but we never really got this kind of like grand vision of just deploying an app in it and the resources become available that it needs based on, you know, a set of tags or labels or whatever. That level, that next step never happened. If you look at like OpenShift and the 3X series, they started supporting service brokers at some point, and you could register a service broker in the same like OpenShift service catalog that had like the list of operators that were available and things like that. And Percona actually shipped a service broker for OpenShift as part of our PXE operator, and it worked pretty good. Like you could, you know, when you go into the OpenShift dashboard and you go to create a new application, it would give you like a drop down and you could select, you know, what you wanted, and it would create the application binding. But there was never, it never got to the point where you could have like a complex set of components that all kind of came together. It never reached that point. And then I haven't really seen it be emphasized as much. I think it's still present and capable in the latest OpenShift in the 4X series, but it's like not a thing anybody just,
it's one of those
really
network
focuses on anymore.
effects where you're not going to actually use it unless everybody is using it. And so it's not super valuable unless you can do it with everything.
Yeah, and it never really caught on anywhere else that I saw, which is sad because the Open Service Broker API was like, it was a bunch of different companies. SAP was involved, IBM was involved, Microsoft was involved, like Red Hat was involved, Google was involved, Pivotal was involved. Like all these companies were into it, and it just kind of like fizzled.
Yeah, that is a bummer. Well, hopefully, because we are talking about it now, maybe it gets some new life injected into it and somebody picks it up and runs with it and it ends up being something. But I see the vision for it. I see what you're talking about. There is a lot of potential there. And so it is sad to see that it never went anywhere and the choice was made to focus attention and energy on something else. And just a quick one before, I know Bart has a question for you, but fungible means mutually interchangeable.
That's
I
a
learned,
good definition.
there you go. And you used it very well there. So I learned something. Well, I've been learning a few things new in this chat, but that one is very concrete. Now, Bart, I know you had some questions for him.
Well, I mean, I think the thing we can say here is that Tyler is definitely not an easily fungible speaker. Not easily, you're not either. No, it's true. So this will tie in nicely, I'm sure, on Twitter and LinkedIn. We'll get that in there. So to shift a little bit more into a different area, something that really caught my attention when we were doing our homework about, okay, we're going to be talking to Tyler. Let's try to get prepared. From looking at your LinkedIn, it's not common that I see people listing soft skills, and you also put your Myers-Briggs personality on there. What is the relationship that you find? We've talked about the technical components that are necessary, things to keep in mind in terms of how we approach these things, that there's going to be, these things about trade-offs, and inside teams that are working together on these things, whether it's Kubernetes, whether it's security, whatever it happens to be. How do you approach that issue of compatibility and creating a good human stack, I guess we could say, of different skills, and the importance of that for anybody who wants to have a solid team?
Yeah, absolutely. So I think team building is like critical to success with technology. You really need to build teams that are diverse and bring together a wide range of experience and personality types to solve problems most effectively. And I really got introduced to this idea of like the importance of understanding your personality and the personalities of the people on your team when I was working at Rackspace. They have a system there that they use internally called Strengths Finder. That's a Gallup. I also list my Strengths Finder strengths on there. It's a Gallup personality assessment. And Graham Weston brought that into Rackspace. And so at Rackspace, every person on their desk has their name tag with their name on it and a list of their top 5 or top 10 strengths. And they funded teams internally to get extra training called through a program called Strengths for Teams, and it really helped in my first exposure to it, and I advocated for it afterwards to understand the people on your team, how they work, how they communicate, and how to most effectively work together to solve problems. And I think it's really important to understand the types of people you work with to understand how to approach them best and like what's the most appropriate communication style. It's something I kind of miss that I don't see at a lot of other companies ever since I left Rackspace. But being able to like walk up to someone's desk and having never met them before, but having an idea of like what the right way to approach them was about
Well,
something was
and of
amazing.
course, it's just an easy conversation starter. Like, oh, it's okay, you're an introvert. Well, my neighbor is, or maybe I am too, or things like that. I think it's so important to be upfront and transparent about it. Like we see these memes making fun of job advertisements for DevOps, saying must have 10 years of experience with Kubernetes and things like it makes you laugh. But in the same way with as people, like not everyone is going to have all of these things, and that's totally okay. There are tons of qualities that Demetrius has that I don't, and vice versa. And I think Dimitri, we actually probably should do one of these personality tests just to do because that way you make sure that everyone focuses on the things that they need to focus on, and that if some things just aren't going to work, it's probably best just to leave them alone. But I think it's something that I definitely think more companies need to do in order to get that right balance. You can't have a team of 5 people with everyone with exactly the same personality. It's probably not going to work very well. They may be very smart, they may have a lot of experience, but you will get clashes, and we see, and there are tons of clashes and horror stories that lots of companies go. I always tell the same story, but in my previous company, the crushing battle between Jenkins versus Team City, I remember, went on for weeks, and just Slack debates going on were on fire, and people getting really angry and thinking about leaving the company because of these personality conflicts. That was it really about the tools? Was it about egos? I think there's a big sociological element that always has to be taken into consideration in any company. And it was just good to see that in your profile, because it's not something we come across frequently.
Yeah, I think if you build a good team of diverse people, you'll end up being less distracted by those sorts of things and really focused on what it takes to succeed together. And that team will want to succeed together because you're lifting up everybody together when you're working on the problems that actually matter for your team.
Brilliant. I'm just trying to rack my mind on what we're going to name this podcast episode.
Trade-offs. Trade-offs.
We've talked about so much good stuff. And really, Tyler, you're so versatile in what you're able to talk about, and the depth of your knowledge in all these different areas it's admirable. And I really appreciate you sitting down here and schooling us and letting us know what is up with Kubernetes and how you see things. There's so many great metaphors that you've given, and also like just looking at Kubernetes as an operating system is huge for me, because it opened up a door in my mind that I did not see it as that before now. And now that I see it as that, it's like, oh yeah, that makes complete sense. It shows me a new way of it gives me a new perspective on things. So I really appreciate that, and I hope that we can do this again. I really want to say that. And yeah, thanks again. Thanks, Bart, for joining me. And Tyler, as always, a pleasure, man.
Thank you both for inviting me. I appreciate it.
We'll be in touch. And like I said, prediction 2021, Tyler will be back.
He'll be back. There we go. See y'all.
Take care.